So in this sessions, we are going to learn about the power sequence of the Inventec boards. The Inventec boards numbers start from 6050, and the currently most of the new generation laptops, especially in HP, the 6050A board is very common. Okay, and this make is called the Inventec motherboard. We have seen Compal motherboard, Quanta motherboard. This Inventec is another manufacturer who's making the motherboard. Now, in the new generation laptop, like from the 10th generation onwards, have the two power inputs. One is called the power DC power from the adapter, okay, and another power from the Type C port. So here are the two power inputs. One is the adapter and another is the Type C ports. And the third one is called the battery. Now, in the Type C port, there is a one circuit is called the uh, buck boost converter. The buck boost converter is basically means reducing the voltage and increasing the voltage. Normally we see in the buck converter which they reduce the voltage. These are the different buck converters. This for the 3.3 volt buck converter, then this is the 5 volt buck converter, then the system volt is required for 1.05, 1.8, 1.5, then this is for the DDR4 RAM 0.6, 2.5 and 1.2, and then the CPU core, and the final is the graphics core. So these are the different buck converters generate a different volt for the different chips like the CPU, then the graphic chips, then the DDR4 RAMs, then the BIOS, then the fan, amplifier, etc. So they get the input voltage that is called a PV bat. The PV bat is the input voltage to this all these buck converters, and that voltage is approximately a 12 volt. Okay, this 12 volt is coming from the this battery charging or the buck boost converter. Now here are the two inputs. Suppose you connect the power to the adapter, then the voltage travel from here, and here is a MOSFET which triggers self trigger, and then this 19 voltage will pass to here, and that signal name again will be PVSYS, that is PV system. Okay, here you should get a P system voltage, and that voltage supposed to be 20 volt or 19 volt, is depend on adapter voltage. Okay, but approximately 19 volt, and you should get here this voltage, and this voltage is input to the battery charging section or the buck boost converter. Now this buck boost converter, what is do is he convert that 20 volt or the 19 volt into 12 volt. Okay, so this 20 volt pass to this different buck converter. Now if the adapter the voltage is passes from this circuit and then passes to the system, this is called the PV bat. Output is a 12 volt, and then if the battery needs a charge at that time, here the SM bus, system management bus, which communicate a battery and the buck boost converter, and if the battery asks for the charge, then this chip's drive and signal is called VRABGATE. Okay, you drive this MOSFET, and then this same 12 volt crossed this MOSFET and entered into the battery, and then the battery started charging. Okay, the battery need a 12 volt for its charging. When the adapter voltage is missing, if suppose you are not connect the adapter at that time, the battery voltage this come reverse from the battery. It cross this PV pack and then cross this MOSFET and come here across the PV pack. Okay, and then you see the difference is here is a PV pack and here is a PV back. Okay, just don't confuse in these two signals. Both the signals are different. PV bat is the output signal to this different buck converter, and PV pack is a input signal or the input voltage to the battery. The battery needs a charge. So in this way, this circuit. And here the controller SIO, super input output control. Here the user normally Newton chips, which is called the number is NPCX797HA1BX. So this is a number for the SIO. Now, what will happen if we connect the power to the Type C port? When we connect our Type C adapter, then first thing what happen is the V bus is coming here, and then second thing what is happening is a separate dedicated Type C controller chips. This Type C controller chips request the power to this Type C adapter, then you trigger both the MOSFET, and then this 20 volt pass here, and that voltage is become a PV system, and then this PV system voltage cross this current sensing resistor and come across this buck boost converter, and the buck boost converter convert that 20 voltage into 12 volt, and that 12 volt passes to the different buck converters. Now these different buck converters, to turn on, they require a different enable signals. So once this 12 volt entered into this different buck converter, the first this 3.3 voltage circuit will be turned on. This circuit will be turned on and generate a linear voltage. It's called the 3 LDO. This 3 LDO out from this 3.3 volt section, and this 3 volt is going to the SIO, and the SIO will be turned on. It's like that. And after, when we press the power button, at that time SIO generate this different enable signals called enable 5 volt, 3 volt, then enable 1 V0A, then enable this VRP DDQ, enable VTT, enable DR VR on, then enable graphics. So this the different enable signal generated by uncontrolled by the SIO, and then when the all voltages coming up, so these are the different voltages is going to the different chips. So this voltage is going to the graphic chips, this voltage is going to the CPU, this the CPU core voltage, this 3 voltage is going to the DDR4 RAM, this 3 voltage is going to the again to the CPU, it's called the PCH voltage, this 5 volt is going to the amplifier and the VRM chips on the USB, and this 3 voltage is going to the BIOS, then CPU, audio, networks, all this things, this 3 voltage is going, even LCD also, this 3 voltage is going. So this I given here number. Just suppose your laptop is not powering on. If you have the Inventec laptops, is not powering on, then what you have to do is you have to connect the adapter either to the adapter port, or you can connect to the Type C port, and you have to check this PVSys. If this PVSys is not coming, then you have to check this MOSFET. Okay, this MOSFET may be open, or MOSFET not getting a triggering circuit. If the PV system is coming, then this voltage is entered to this buck boost converter, and then you have to check straight away PV bat. If the PV bat is not coming, P system is coming, then the problem in this sections in buck boost converter. So you have to check why this buck boost converter is not working. If the detail of this, how this buck boost converter is given in a different video. So this voltage goes out. So now if the battery is not charging, then you have to check this particular MOSFET, and you have to check this PRAGB gate signal which trigger this MOSFET. And if this signal is coming, but the battery is not charging, then the possible could be this MOSFET is bad. Okay, if the battery is not detected, then you have to check this SMBus signal which this battery charging chips detect uh, the battery. So you have to check this signal. Okay, so here I given an explanation about the how the Inventec board. I given an overview about this power. So just remember this numbers start from 6050A and dash 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 different number. I hope you understand this concept.